11, so this is like the start of this video, right? If you're at home or for my people that are gone. First thing when you write these equations, you will have one like number 19 on your test when you take the test. And I'm not sure exactly how that test is going to be. So if you didn't have this done, write it down. Write it to the side. Make sure, okay? So distance equals, it's the absolute value of first how far away, right? How far away you started. Minus the speed times time. So when I look at this problem, and as I look at this one, I'm kind of thinking, oh, well, what was the distance? How far away did they say you were going to be when we read that question? So as we read that, it said, oh, I want to know when the person is going to be 200 feet away, which means when I take a look at this, this is the 200 feet. That's my distance. Now, I'm probably not going to put that label feet with it. Just going to put the 200. Equals absolute value. How far away was that person when the float started? They were 750. Even if you're not sure, you didn't do this, write it down so you have all this, right? 200 equals 750 minus, oh, how fast were we going? 158 times t. So we're looking at this problem and we're thinking, oh, okay, does it equal a positive number? Absolute value all by itself? Yes, absolute value is isolated. It equals a positive number. I have to have two cases. I have to have the positive and I have to have the negative. And I'm trying to figure out my time. So I personally like to put this part in the absolute value first. Does it matter if I put the 200 first or the 750 minus? Not at all. I like putting the 750 minus 158t equals 200. That was my positive case. I'm solving that like normal. Subtract 750 both sides. Okay. Here, this was my negative case. The negative case just means I'm going to take 750 minus 158t equals this time a negative 200. Each case, as I start out, I'm subtracting 750. Am I getting two totally different answers when I do that? For sure. You need to take your calculators out. It shouldn't be too bad for you. 158t equals negative 158t. You're probably going to for sure want it for the division, right? So I'm looking at this one, and in that first case, as I look at it, and I set that equal, as I look at that, what are you going to have, Sophia? Negative 158 equals what? Okay, wait, you're taking, so we're going to take negative 550, which makes sense, right? They should both be negative because now I'm going to divide negative 158 on both sides. If I am looking at that second one, Griffin, what am I looking at? When I subtract negative 200, negative 750, negative 950, right? Again, I'm going to divide by negative 158. The time should come out positive, right? When I do that, I get two answers for my time. So many feet per minute. So I can't have the wrong answer label of seconds. We were looking at feet per minute. So how do I know what time? Again, they asked us how many minutes. Minutes. And over here, I'm going to get the other answer, right? So these are my two answers when I divide. So when you're looking at those answers for your minutes, a lot of times thinking about what makes sense for an answer as we are looking at this. So if I looked at this one, we might have our answer as 3.5 minutes and 6 minutes. Questions. 112, 11 to 17 odd, 22 to 25, 37 to 41. This was more what the video was like, right? The video was more like solving these type of problems. That is a lot more of what you will see on the test for the literal equations. It'll be more like this. But you might have ones like the first half of questions 11 to 17. That's because that gets us into our looking at linear equations, which is unit C, I think, where we have to solve linear equations or write linear equations, and you really need them in what's called slope-intercept form when we are looking at that. So, on your notebook paper, I should have your name, right? Period 4, I should have page 112, and then you might put the assignment behind it, right? Then we are going to write down number 11. So, I look at question number 11, and question 11 said, first step for all of these in 11 to 17. Solve the problem for y, then find the value for y for each of the values listed behind. So, as I look at that, y plus 2x equals 5 for x equals negative 1, 0, 3. Number 13 I'm going to put over here because I'm doing my work below. 3x minus 5, y equals 9, x equals negative 1, 0, 1. So when I go to look at your paper, that you're going to send a picture to me, although you guys could actually hand this in tomorrow or show me. I wouldn't say maybe show me in class tomorrow, but maybe you send me a picture when you finish this with your 2 assignments. So, first thing, we are solving for y in both of these. I need to isolate the y. So I'm taking a look at number 11, and I'm isolating the y. If I am doing that, Viola, what would you do to get rid of this plus 2x that's with the y?
Subtract the 2.
So not just subtract 2, but subtract 2x, right? So I subtract 2x on both sides, okay? So I'm looking at it going, oh, I subtracted 2x. So now, Allie, what are you going to do? What would I end up with on this side?
Y equals 5, or y equals
Say what? One more time.
5. Y equals
5.
5. Or y equals 5 minus 2.
5 minus 2x. I had some people go, it's 3x. Are those like terms, the 5 and the x? No. So I would take this answer that Allie just gave us, 5 minus 2x. I am going to try and probably give you, try to have you rewrite it and always put the x term first. Is it wrong if you don't put the x term first? No, this is the correct answer. The reason we're doing it this way is that when we get into what's called slope-intercept form, if you remember that from last year, right, when you guys were doing lines and you found slope in pre-algebra and you found that rate of change, this is a beautiful form, and then I always know my slope is with the x and my y-intercept. So just kind of refreshing your memory that way. So I would take either of these for your correct answer. If you just leave it this way, that's fine. But now I got to do this part of the problem. And that second part of the problem says, okay, if x equals negative 1, 0, and 3, you're going to go to this equation. And maybe you say, okay, x equals negative 1. Then x equals 0, and then x equals 3. If x equals negative 1, and I am looking at that equation, Jacob, which equation do you want to use, first or second? Second. Okay. Did you find your stuff? Oh, bummer. Y equals negative 2, and then we're going to put in what? Instead of x, it was keep going. What was x equal to? Negative 1. And then I'm putting the rest of the equation plus 5. And the question said, well, what does y equal when x is negative 1? So you're just solving that now. So if I am taking a look at this, I have negative 2 times negative 1, which is 2. 2 plus 5, y is 7. So in the back, you saw the answer for the equation, and then you saw the word. Okay? So, Katie, we're going to do that next one when x is 0. So I'm going to write down y equals,
negative 2.
wait, so negative 2, okay,
And then parentheses 0.
times 0
Plus 5.
plus 5. So when I do that, negative 2 times 0, love that, right? Don't have to think. Plus 5, y equals 5, right? Benjamin, or Ben, sorry. Y equals?
Negative 2 parentheses 3 plus 5.
So negative 6, right? We're going to do our multiplication order of operations. Plus 5 gives me a negative 1. So these are the other 3 answers that you probably saw in the back. Okay? So let's look at 13 and at least start 13 together. Okay? And then we'll kind of use the time for you guys to work on questions on other ones if you had questions on some other ones here. So 13, if you didn't write down the problem, write down the problem on your paper. We had 3x minus 5y equals 9. And I will put the textbook page back up. I do have a few extra textbooks in the back if you don't have yours with. Same thing tomorrow. I do have a few extras in the back if you're still working on this. So number 13, my first step is I need to get the y by itself. If I'm trying to get the y by itself, what are you thinking of, Riley?
We have to subtract 3.
Subtract 3x. So we subtract 3x from both sides of our equation. I'm going to now have a negative 5y. Most common mistake, people will just put 5y instead of negative. Okay. We're going to continue. Isaac, on this side, what would we end up with? 9 minus 3x. This looks so ugly. It is ugly. What do we have to do now to solve for y? What's happening with the y and negative 5? What operation is happening right here? They are being multiplied. So the opposite of multiplying by negative 5 is to divide every single thing by negative 5. This divided by negative 5 gives me y equals. That's what they asked us to do. They said solve for y. Next thing, I'm going to divide by negative 5 and negative 5. Someone said, can I put the whole thing over that negative 5? You could, but here's the deal. If I look at negative 9 divided by negative 5, is that pretty easy to turn into a decimal because I'm divided by 5? It's a terminating decimal, right? 9/5 means 5 goes into 9. Well, we know 5 goes into 10 2 times. This is negative 1.9 divided by 5, 1.8. If you're not sure, take your calculator out, do the division, right? Here I have negative divided by negative. That is just going to be 3/5. Oh, I'd prefer not to do fractions on my calculator, right? Because I'm plugging in these numbers. Can I change that to a decimal also? 3/5 is 0.6x. Is that okay? Yes. When we're in graphing and slope-intercept, do I want you to change the fractional slope to a decimal? No, never, 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 because it tells me about my rise and my run of my slope of my line. But in this problem, we're not to that yet. It just says solve it for y. What if the answer in the back has 9/5 plus 3/5 x? Is that what you had here? They're the same thing, right? It's just writing it differently, okay? What are we plugging in for our x values this time? Negative 1, 0, 1. Okay? So if we are going to start out, Marissa, what are we going to have for the first one that you would be writing down?
Y equals negative 1.8 multiplied by negative 1 plus 6.
Really close, but not quite. Did the 1.8 have times x? No. So do you see her mistake? So that is why I like to put the x1 first, because then I'm like, oh yeah, but you are simply replacing this x. So nope, it doesn't go here, it goes Can I put the whole thing in my calculator as I'm looking at this? For sure.
You have a piece of paper that you're participating with this one.
So, negative 1.8 plus negative 0.6. I don't know if you need your calculator for that. You might not, right? They're both negatives. You're going to add them together. And then you're going to get that answer. You can do the same thing with the 0, right? You can do, oh, we love the 0, because what's my answer going to be when x is 0? Just negative 1.8, right? So here I already know y equals negative 1.8. Do I really have to do much work with that one? That one is 0. We love 0. That's our special number when we get to graphing equations. When x is 0, that's our y-intercept. So we get to that. That gets to be really special to us later, okay? So that's how you're doing the first 4 questions, right? Where you were taking a look at this assignment at questions 11 to 15. So we've started 11 and 13, pretty much almost done with them. So you just have 15 and 17 that are the same type. As you look at 19 to 27, those questions that we are looking at, so the 22, I guess it is, to 25. So as we look at these, and we look at 37 to 41. Anyone have any other ones that you would like me to yeah, that's ugly, I'm not sure how to start or what I should do? Because I would look at a couple others as a whole class. Where's the?
Could you do 27?
Could do 27. Why? We didn't assign 27, did we? No. You're not going to have to do one that ugly on the test. Don't worry about 27. You want 37 instead?
Sure.
Or is 27?
37.
37. Okay, not doing, and again, this one, but so let's look at 37. So, for 37, I'm going to do the work kind of over here to the side as we are looking at 37. So, if you want to leave some space or go to the back of or if you want to do it right below 13 and 15, I don't care. But, write down number 37. We're going to do this one together, and then I'm going to let you guys work, and as I can walk around and help you as much as possible. X divided by A minus 1 equals y divided by b, and we are asked to solve for x. That means I want the x by itself, okay? So I look at the problem and I go, well, what do I have to look at isolating first? I need to isolate this, because that's the thing that has an x with it. So, how do I get rid of a minus 1? I add 1 to both sides. Here's your equal sign, add 1 back here. I might not even put it below it, I might put it behind it, because these are not like terms, right? So when you think about your like terms when you are going back to other vocabulary, so this is going to be x divided by a, these cancel, equals y divided by b plus 1. What is happening to the x? X is being divided by a. What's the inverse or opposite of dividing by a? Multiplying. I need to multiply everything by a. So I'm going to take this times a, which is the same as a over 1, right? Over here, I'm going to take this times a, and I'm going to take each term times a. Could I have distributed it? Yes. Can I just do it each one times that, whatever it is? Yeah. These cancel. A over a is the same as 1, so I now have what I was searching for, x by itself. Does it matter if you put ya or ay? Doesn't matter, right? These are being multiplied. So if the answer in the back doesn't have ay and it has ya instead, we know that those are the same because you're just multiplying them. You still have b in the denominator. Plus, could you just leave this as an a? Yes. I don't know if this one has it factored out an a in the answer in the back. But the factored out answer would have just looked like this. It would have said x equals a times yb plus 1. I would take either of these answers. They're both the same thing. It's just that one has it like out by itself. Okay? So